if I'm dealing with all real numbers, I usually start at -2, -1, 0, 1, and 2. So I pick 0 in the middle and go either way and try to get as much of the graph as possible. That's why transformations become so important, because yesterday I was graphing a square root function in intermediate, and because there was a transformation in place, it was shifted to the left and it was shifted down, we couldn't get all the graph by using this. We just got a half of it because of the shift. Well, they don't know anything about transformational shifts. So in order to get the whole thing, they'd have to plot a heck of a lot more points. So this would be 3 to the -2, which is 1 over 9. 3 to the -1, which is 1 over 3. 3 to the 0, which is 1. 3 to the 1, which is 3. 3 to the 2, which is 9. So at -2, we're about 1/9, 1/3, 1, 3, and 9. So those are my points. And since we're big people now, we can say, if I'm looking at y equals 3 to the x, as x gets bigger, three to the x also gets bigger. In calculus, that's called limits. Because the bigger x gets, you notice the bigger 3 to the x gets. Now that means for my graph, this is going to continue upward. And as x goes to -infinity, gets smaller, 3 to the x gets smaller. And in fact, how small does 3 to the x get? Yeah, 3 to the x is always positive. So if I take a look at what's happening, it becomes more fractional. So that would be 1 over 27, 1 over 3 cubed, 1 over 3 to the 4th, 1 over 3 to the 5th. It's always positive, but it's getting smaller and smaller and smaller and smaller. So 3 to the x will go to 0, never reaching 0, but goes to 0. So this means he has a horizontal asymptote at y equals 0. That's going to be a characteristic of the exponential function, the basic exponential function. Because when you do transformations, asymptotes will travel with the function. So what do we know about the exponential? We know his domain is all real numbers, and he has, I'm going to call him an HA, horizontal asymptote, at y equals 0. And if you're going to eventually take the calculus class, that's going to be quite handy. So what does that mean? I've got an HA here. And this graph is going to continue to ride along the x-axis. It shouldn't lift up. And all exponentials look alike. It's like parabolas. All parabolas look alike. It's just going to be the placement on the paper. All exponentials look alike. It's just going to be the placement on the paper. So here's another exponential function, 1/5 to the x. He's not any different than 3 to the x in the fact that he's got a base raised to a power. And why did they make that 1/5 cubed? This should be an x. This came from you can see it's got a little blue box, a little box around it that came from the lecture thing. Should be an x. Using a table of values. Isn't that exciting? Well, let's see what's going to happen. This is x. This is going to be 1/5 to the x. So -2, -1, 0, 1, and 2. This is why they, by the way, this is why they did that -1 thingy on you. This would be 1/5 to the -2. This is going to be a flippin' square. So this is a 5/1 squared, which is 25. This is 1/5 to the -1. That's just a flip, so that's 5. This is 1/5 to the 0, which is 1. This is 1/5 to the 1, which is 1/5. This is 1/5 squared, which is 1/25. So now you notice as x goes to negative infinity, my y values are getting bigger. And so as I get more negative, the y's are getting bigger. And as x goes to infinity, my y's are getting smaller. So that -2 is off my graph paper. It's up here someplace. -1 is 5. 1, 2, 3, 4, 5. 0 is 1. 1 is 1/5. 2 is 1/25, and he looks just like the other guy, except flipped around the y-axis. And if I take a look, his domain is all real numbers, and his range is 0 to infinity. He has an HA at y equals 0. Ranges we don't worry a whole lot about, but domains we do.